Welcome back to our series where we are covering problems from Chapter 5, 11th Standard NCERT. Let us continue. Question 5.29. 10 1 rupee coins are put on top of each other on a table. Each coin has mass m. We have to give magnitude and direction of the following forces. For A, we have the force on the 7th coin counted from the bottom due to all the coins on its top. So after 7 we have 8th coin, 9th coin and 10th coin. So if this is the 7th coin, we have 8th coin, 9th coin and 10th coin. So force on 7th will be mass multiplied by gravitational acceleration of these three. So this would be 3 mg. So force on 7th coin due to all the coins on its top would be 3 mg downwards. It would be 3 mg downwards. Okay. Now B part is the force on 7th coin by the 8th coin. This will be same as the one in A because 8th coin and 7th coin are in contact. So all this force will be exerted by the 8th coin on the 7th coin. So it will be same 3 mg downwards. 3 mg downwards. Okay. Now C part is the reaction of 6th coin on the 7th coin. So 6th coin will face mass into gravitational acceleration of 4 coins, 7th coin, 8th coin, 9th coin and 10th coin. So force on 6th coin would be 4 mg downwards. So that is force by 7th on 6th. So due to Newton's third law, equal and opposite force will be exerted by 6th coin on the 7th. So reaction of 6th coin on the 7th would be 4 mg and direction would be upwards. Direction would be upwards. So this is a question where we have to think. Calculation is not that important in this question. We need to learn how to think, how to tackle the situation. Let us move ahead. Question 5.30. An aircraft executes horizontal loop at a speed of 720 km per hour. Let us convert it into meter per second. So 720 multiplied by 5 upon 18. So this would be 40 into 5, which is 200 meter per second. So speed of the aircraft is 200 meter per second and its wings are banked at 15 degrees. So theta is 15 degree. So what is the radius of the loop? So here friction would be 0 because it is in the air. So theta is 15 degree. So we know tan theta is v square upon rg. Tan theta is v square upon rg. G is 10 meter per second square. G is 10 meter per second square. R is the radius of the loop. R is the radius of the loop. Therefore, we will get R is equal to v square upon g tan theta. V square upon g tan theta. So this would be 200 multiplied by 200 divided by g is 10 multiplied by tan of 15 degree is 0.2679. Tan of 15 degree is 0.2679. So this would be 4000 upon 0.2679. So this would approximately come out to be 14.9 kilometer. This approximately comes out to be 14.9 kilometer. That would be the radius of the loop. 5.31. A train runs along an unbanked circular track of radius 30 meter. So R given is 30 meter at a speed of 54 kilometer per hour. Let us convert it into meter per second as soon as we get it. So this is 54 multiplied by 5 upon 18. So 15 meter per second. 15 meter per second. Mass of the train is 10 to the power 6 kg. What provides the centripetal force required for this purpose? Engine or the rails? So because it is an unbanked road, unbanked circular track, the engine will only push it forward. So the acceleration towards the center of the circular track will be through the rails, through the friction of the rails. So A part, centripetal force would be rails. Rails would provide centripetal force. Rails would provide centripetal force. Now the next part is, what is the angle of banking required to prevent wearing out of the rail? So if we want to prevent wearing out of the rail, we would need no friction between rails and the circular track. So there we will use the banking formula. So tan theta is V square upon Rg. Tan theta is V square upon Rg. So V is 15 into 15, R is 30, G is 10. So we get 2 za 1 za. So 15 upon 20, which is 3 by 4. So theta is tan inverse 3 by 4, but we know this is 37 degree because in Pythagorean triplet 3, 4, 5, smallest angle is 37 degree. Hence we get angle of banking required is 37 degree. Angle of banking required is 37 degree. Let us move to the next question. Question 5.32. A block of mass 25 kg is raised by a 50 kg man in two different ways as shown in the figure. What is the action on the floor by the man in the two cases? If the floor yields to a normal force of 700 Newton, which mode should the man adopt to lift the block without the floor yielding? So we have to find the normal force being applied by the floor onto the man. So normal force onto the man, that we need to calculate, and if that exceeds 700 Newton, then the floor will yield and it will collapse. So let us consider case A. What we will do is, because the man is not moving, we will balance all the forces acting on the man. We will balance all the forces acting on the man. So let us draw free body diagram of the man. So one would be, small m is block of mass, so that is 25 kg, and big M is mass of M, that is 50 kg. Big M is mass of M, that is 50 kg. Now here we have capital Mg, which is weight of the man, and also because the man is directly lifting up the box, we also have to add small mg, and everything is countered by normal force N. So let us call it N1. Therefore N1 will be M plus M into G. So this would be 750 Newton. This would be 750 Newton, which would lead to the floor yielding. So the floor will yield greater than 700 Newton. Greater than 700 Newton. In the second case, let us draw free body diagram again. We have now the tension is upwards here. So here also the rope will pull the man upwards with mg. So here it will pull upwards with mg. Weight is capital Mg, and this is normal N2. Therefore N2 will be M minus M into G. So that would be 250 Newton. 250 Newton, which is less than 700 Newton. Which is less than 700 Newton. So method 2 should be used. Method 2 should be used. Method 2 should be used. That will not yield the floor. In method 1, the floor will yield and the person will collapse. The person will collapse. Let us move to the next question. Question 5.33. A monkey of mass 40 kg climbs on a rope which can stand maximum tension of 600 Newton. which can stand maximum tension of 600 Newton. In which of the following cases will the rope break? So let us see case 1. In case 1, monkey is climbing up with acceleration of 6 meter per second square. Let us draw free body diagram of the monkey. So let this be monkey. So first and foremost, weight of monkey mg, tension of the rope T, and moving up with acceleration 6 meter per second square. So acceleration upwards. Therefore, MA will be T minus mg. Therefore, tension has to be M into A plus G. So let us calculate what would be the tension if the monkey is climbing up with an acceleration of 6 meter per second square. So this would be 40, mass of monkey is 40 kg. So 40 multiplied by 6 plus 10, so 16 for the 64. So it will be 640 Newton. 640 Newton. So this is greater than 600 Newton. So it will not be possible. The rope will break. The rope will break. What is the next case? The monkey climbs down with an acceleration of 4 meter per second square. Again, free body diagram. Weight mg, tension upwards T. Now acceleration is downwards A. Okay. So mass into acceleration will be mg minus T. Mass into acceleration would be mg minus T. Therefore, we would get tension is equal to mg minus A. mg minus A. So this would be 40 multiplied by 10 minus 4. So 6 4 are 24. So this will be 240 Newton. So this would be 240 Newton, which is less than 600 Newton. Which is less than 600 Newton. Therefore, here the rope will not break. The rope will not break. Now the third condition, C, is climbs up with uniform speed of 5 meter per second. So there is no acceleration. There is no acceleration. Therefore, T will be equal to mg. T will be equal to mg. So that would make 40 into 10, 400 Newton. 400 Newton, which is less than 600 Newton. Therefore, rope will not break. Rope will not break. And finally, we have what will happen if the monkey falls down under gravity. So falls down under gravity, that would mean the acceleration is g downwards, which is solely due to force of gravity. So tension is 0. Tension is 0. So rope will not break. Question 5.34. Two bodies A and B of masses 5 kg and 10 kg in contact with each other rest on a table against a rigid wall. The coefficient of friction between the bodies and the table is 0.15. Force of 200 Newton is applied horizontally to A. What are A, the reaction of the partition, and B, the action-reaction forces between A and B? Okay. So, when they are against a wall, both A and B are not moving. So what would be free body diagram of A? So 200 Newton this way, and here reaction on A from B. So because A is not moving, our A of B would be 200 Newton. 200 Newton towards left. Towards left. This is object A. Now for object B, what will happen? This is R of on B due to A. Okay, and this is reaction due to wall. Reaction due to wall. This magnitude would be 200 Newton. So reaction on the wall, reaction from the wall will also be 200 Newton. That too towards left. Towards left. And action reaction forces between them would be 200 Newton. Action reaction forces. These are action reaction forces, action reaction forces. Now what will happen when the wall is removed? What will happen when the wall is removed? Now when the wall is removed, this is object A, it has a force 200 Newton, it has a force 200 Newton towards right, it has reaction on A due to B, RAB towards left, and also it will have a frictional force. Let us call it FA, frictional force FA. For object B, we will have reaction on B due to A, reaction on B due to A, and frictional force FB, frictional force FB. Now let us calculate what will be the frictional forces on each of them. So what will be their individual frictional forces? Now if we assume that they will move, FA will be mu into MA into G, so 0.15 into 5 into 10. So it would be 7.5 Newton, and FB would be mu MB into G, so this would be 0.15 into 10 into 10, so that would be 15 Newton. So these would be their frictional forces. These would be the frictional forces. Now if we treat them as a one single system, if we assume that they will move together, what is the net force on the system? Net force on the system is 200 minus 7.5 plus 15, and acceleration A would be divided by the total mass, which is 15. So it will be 200 minus 22.5 upon 15, which is nothing but 177.5 upon 15, which comes out to be 15 ones are 11.83 meter per second square. So they will accelerate with an acceleration of 11.83 meter per second square. Now we have to find their action reaction forces. Their action reaction forces. We will just calculate the reaction force for A, and the direction of reaction force on B would be opposite, magnitude would be same. Magnitude would be same. We have 200 minus R on A due to B minus F of A, that divided by mass. How much is the mass? Mass is 5 kg, that is equal to acceleration 11.83 meter per second square. So this would be 200 minus RAB minus 7.5 to be equal to 5 into 7.5 divided by 15. Therefore RAB is equal to 192.5 minus 59.167. So this would be 133.33 Newton. 133.33 Newton. So reaction on A would be towards left, and reaction on B due to A would be 133.33 Newton towards right. This would be towards left. This would be towards left. So let us meet with the remaining problems in the next video. Thank you.